Topics in demand and supply analysis. This is the first reading in economics, and if you do not have a background in economics, I would strongly recommend that you go over the prerequisite readings which are available on the CFA Institute website. This reading has two major sections: demand analysis, which has to do with the consumer, and supply analysis, which has to do with the firm. Let's start with a very basic introduction. Since this is the first reading in economics, we talk about the definition of economics. There are many different definitions, but here is the one that is used in the curriculum. Economics is the study of production, distribution, and consumption. It is divided into two broad areas: microeconomics and macroeconomics. Macroeconomics deals with aggregate economic quantities such as national output and national income. So terms such as gross domestic product will be used in macroeconomics. Microeconomics deals with markets and decision making of individual economic units, which includes consumers and businesses or firms. And this reading is a microeconomics reading. So let's start with section 2, demand analysis. This is a fairly long section and it has 6 subsections which are shown over here. Demand concepts. Here the first point to learn is the law of demand. According to this law, as the price of a good rises, buyers or consumers will choose to buy less of it, and as the price falls, they buy more. So if you have a particular good such as chairs, when the price of chairs goes up, the quantity of chairs demanded, all else equal, typically will go down, and on the other hand, if the price goes down, the quantity demanded will typically go up. This is the law of demand. When we are talking about a particular good such as chairs, the price of that particular good is referred to as the own price. Now let's take this concept one step further and talk about the demand function. The demand function points out that the demand for a particular good, let's say good A, depends on or is a function of multiple variables. So obviously the demand for a particular good is a function of the price of that good. So demand for good A is a function of the price of A. It is also a function of the income levels. So you can imagine that in general, if incomes are higher, then the demand will be higher. It can also be a function of the prices of other goods. So let's say the price of tables impacts the demand for chairs and so on. Now here is one particular demand function. So let's continue with the chair example. We can say that in a given small town there is a demand for chairs, and the demand function is given by this expression. Now you don't need to know exactly where this came from. In the exam world, you will typically be given the demand function. So here what we are told is that the demand for chairs is equal to 10 minus 0.5 times the own price. So in my convention, when I don't use a subscript, I'm assuming this is the price of the good that we are talking about. So if we are talking about chairs, this is the quantity demanded for chairs and this is the price of chairs. But we are saying that the quantity demanded also depends on the income level. So this I represents the average income level in this town, and the quantity demanded for chairs also depends on the price of tables. So this is the average price level for tables in this particular town. If we take a given value for income, so let's say that in this town the average income level is 1633 and on average the price is 800, then we can plug in 1633 over here and 800 over here, and that will give us this expression. So this is expressing the demand for chairs purely in terms of the price of chairs. Now using algebra, we can express this function in terms of the price, and that's called the inverse demand function. So we can say that the price is 200 minus 2q. So if your algebra is weak, I'll show you very quickly how this is done. So you have minus 0.5p. This can go to the left of the equal to sign. So we can say 0.5p is equal to 100 minus, and then the q can come over here. So minus the quantity demanded, and then from this, if we divide everything by 0.5, we have P is equal to 200 minus 2Q. So this is called the inverse demand function. Given this inverse demand function, we can very easily plot the demand curve. Notice that P is the y-axis over here. So when we draw the demand curve, the price is on the y-axis, the quantity is always on the x-axis. This point over here is 200. So this comes from over here. When the quantity is 0, the price is 200. What about this point? If the price is 0, then the quantity is 100, and the slope is given by minus 2. So the coefficient of Q is the slope. So we can say that this slope is minus 2. The minus is important because this is saying that as price comes down, the quantity goes up, or alternatively, as the price goes up, the quantity demanded goes down. So price and quantity move in an opposite direction, which is why the slope is negative. A couple of points to note regarding this demand curve. This demand curve tells us the highest quantity consumers are willing to purchase at each price. So let's say that the price is 100. This demand curve tells us the maximum quantity that consumers are willing to purchase at a price of 100. The other way of looking at it is that the demand curve tells us the highest price consumers are willing to pay for each quantity. So if the quantity is 75, this price over here will be the highest price that consumers are willing to pay. Now this is a point that's covered in the prerequisite readings, but I'll still emphasize the point over here. When we have a particular demand curve, and the only thing that changes is price, so the own price of chairs changes, then we move along the curve. So movement along the curve is when there is a change in price or a change in quantity of chairs. So these two move together along this curve. If anything else changes, such as the income level or the price of tables, then the demand curve will shift. So very simplistically, if overall income levels go up from 1633 to say 2000, then if you come up with a new demand curve, you'll notice that it will be higher than this particular demand curve. So again, remember, if the own price changes and nothing else changes, then we move along the curve. If something other than the own price changes, such as income or the price of tables, then the demand curve will shift. In the next segment, we will cover the elasticity of demand. But before we go there, I want to discuss a very simple mathematical rule with you. Now, those who remember their high school calculus will find this familiar, but if you don't remember your high school calculus, it's not a problem. Just understand this basic rule that I am talking about, and then the subsequent segments will become much easier. So let's say we have an expression like this. A variable A is expressed in terms of other variables such as B, C, and D. Then the change in A divided by change in B, or delta A over delta B, is equal to the coefficient of B. In this simple expression, the coefficient of B is 5. So delta A over delta B is 5. This assumes that the other variables are held constant. So if C and D are held constant, then change in A over change in B is 5. Now what if B and D are held constant and we want to find delta A over delta C? That is simply the coefficient of C. So the coefficient of C is minus 6. And similarly, delta A over delta D is equal to 8, which is the coefficient of D. Now, if we go to our demand function from the earlier slide, this is the demand for chairs, which is given by this function. The demand for chairs is 10 minus 0.5 times the price of chairs plus 0.06 times the income level in our town and minus 0.01 times the price of tables. So here, if I ask you what's delta Q, and this is the quantity demanded of chairs, divided by delta P, and P is the own price of chairs, the answer is this coefficient. So what you should be coming up with is minus 0.5. Now you tell me, what is delta Q over delta I? You're right, that is 0.06. What about delta Q over delta PT? Now this is the price of tables, and again you are right, the answer is 0.01. Now we come to section 2.2, which is the own price elasticity of demand. So what does this mean? Again, go back to our chairs example. The own price elasticity of demand deals with how the quantity of chairs demanded is impacted by the price of chairs, keeping all else constant. At a basic level, we know that typically if the price goes up, the quantity will come down. But the elasticity tells us by how much. The formal expression for elasticity is shown over here. So this E with the subscript and this postscript is telling us what we are coming up with. The D stands for demand. So we have the elasticity of demand, and the Px stands for the own price. So we are assuming that we are dealing with good X. So if the price of good X changes, then what's the elasticity of demand? That is given by the percentage change in quantity demanded for good X divided by the percentage change in the price of good X. Now, this percentage change can also be shown like this. The percentage change in quantity can be written as the change in quantity divided by the original quantity. So if we started out with a quantity of 100 and then there is a small change, the percentage is given by the delta change, or this is the change divided by the original amount. That gives us the percentage change. And similarly, the percentage change in price is given by the delta P, which is the change in price over the price. And then this can further be simplified into this expression. So change in quantity over change in price times price over quantity. Now I'm keeping things simple here. We are talking about chairs. So this is the quantity demanded for chairs. This is the price of chairs, or these are actually the deltas or the changes. And then P is the price of chairs, Q is the quantity of chairs. So if I were to ask you what's the own price elasticity of demand given this expression, so hopefully now the basic maths lesson I gave you will help. If we want to find the own price elasticity of demand for chairs, we use this expression. What is delta Q over delta P? That is simply this coefficient over here. So that is going to be 0.5 times P over Q. Now on your exam, if you get a question like this, you will have the expression and you will also be told that the price is this much and the quantity is this much. So you might be told, for example, that the price is 50 and the quantity is, let's say, 90. So if you are given these two numbers, then you can just plug in the numbers and come up with the own price elasticity of demand. Now let's dig a little deeper. As we've seen earlier, typically the demand curve is downward sloping. We always have price on the y-axis, quantity on the x-axis. So what this is saying is that over here, when the price is this much, the quantity is 0. So if the price is too high, there will be 0 demand. And as we decrease the price, the quantity demanded increases. There are some exceptional cases where we might have an upward sloping demand curve, but we'll deal with those cases later. For all negatively sloped linear demand curves, so linear means this is a straight line, elasticity varies depending on where it is calculated. So consider this demand curve. The equation is shown over here, and I've just plotted some points. So this point where the quantity is 0, the price is 200, and you can see that over here. If quantity is 0, price is going to be 200, and where the quantity is 100, that's this point, the price is going to be 0. So this is a simple linear demand curve. So a few more points on this curve. So at this point, when the price is 198, the quantity is 1, and again that's based on this curve. When the price is 100, the quantity is 50, and when the price is 2, the quantity is 99. Now I want you to calculate the elasticity at these 3 points. So let's say this is point A, B, and C. So using the formula, and that's this formula, what is the elasticity at point A? We've already seen that this part of the expression, change in Q over change in P, is going to be constant for a linear demand curve, and that constant is this coefficient. So at point A, the elasticity is going to be minus 0.5 multiplied by P over Q. So at this point, P is 198 and Q is 1. So the elasticity here is minus 99. This is extremely elastic. So at this stage we are very elastic, which means that a small percentage change in price will have a huge impact on the percentage change in quantity. So this is clearly an elastic portion of the demand curve. What about point B? Here the elasticity is again 0.5 or minus 0.5, because this part doesn't change, multiplied by the price over quantity. Price is 100, quantity is 50. So notice this gives us minus 1. This point, therefore, point B, is called the unit elastic point. Unit elastic point means that a 1% change in price causes a 1% change in quantity. And then what about point C? Here we'll have minus 0.5 multiplied by price over quantity. Price is 2, quantity is 99. So you'll notice that this is a very small number. So a percentage change in price has a very low impact on the percentage change in quantity. Therefore, this part is called our inelastic part. And now you can see the progression along this demand curve. Here we are elastic, and as we move down, the numerator, which is the price, comes down, the denominator, which is the quantity, goes up. So this fraction is clearly coming down, which means that in absolute terms the elasticity is coming down as the price decreases. We come to point B where we are unit elastic, and as we go further down we become more and more inelastic. So that illustrates this point. For all negatively sloped linear demand curves, elasticity varies depending on where it's calculated, and now we've shown that elasticity is high in this region, low in this region, and we have unit elasticity over here. You also need to understand the concept of a perfectly elastic demand curve and perfectly inelastic demand curve. So if we have price over here, quantity over here, a perfectly elastic demand curve is horizontal. So notice that a very small change in price over here has a huge impact on the quantity. Perfectly inelastic would be something like this. So with a perfectly inelastic demand curve, no matter what happens to the price, the quantity remains unchanged. So just remember this: perfectly elastic horizontal demand curve, perfectly inelastic vertical demand curve. There are several factors that affect demand elasticity. Probably the biggest one is the availability of close substitutes. If for a given product there are several close substitutes, then the elasticity is going to be high. Consider, for example, a product, let's say the Toyota Corolla car. Now, the Toyota Corolla has several close substitutes, such as the Honda Civic or the Lancer, and if you are in the US, there will be several American cars that are close substitutes. If the price of Toyota Corolla goes up, the quantity demanded of this product is going to come down substantially, because consumers will then move towards other cars that are similar to the Toyota Corolla. So keep this in mind. If there are several close substitutes, then the own price elasticity is likely to be high. Now, when we consider a good, it's also important to think about how we consider a good. So here we thought about a particular type of car. What if our product is much more broadly defined? So if our broader product is cars, then substitutes are available, but they might not be very close, and also it might depend on which city you are in. If you are in a city like London, then other types of transport such as the underground rail might be easily available. On the other hand, if you are in a city like Dallas, then there might not be so many close substitutes. But let's consider a city like Dallas where there is effectively no public transportation. Now, there obviously the substitutes are not easily available. So if we define our category as cars, then a change in price is not likely to have a huge impact on the quantity demanded. So in this case, the elasticity will be relatively low. Next point, portion of total budget. Now, the key point to remember is, if a given product represents a high percentage of your budget or the consumer's budget, then the elasticity is also going to be high. Consider cars versus bread. So obviously bread will represent a small percentage of a typical household's income. Now, if the price of bread goes up by 30% and the price of cars goes up by 30%, the impact on the quantity of bread demanded is going to be marginal. So we can say that this is relatively inelastic. The elasticity will be rather low. On the other hand, the price of cars is obviously high relative to bread, and this represents a higher percentage of the budget for most people. So a 30% increase in the price of cars is going to have a much larger impact on the demand for cars relative to a 30% increase here in the price of bread. So the higher the portion of the total budget, the greater the elasticity. The next point has to do with the time horizon. Here the quick point is that if the time horizon is long, then the elasticity will be relatively high. So let's go back to our cars example. Now, if the price of cars goes up by 30%, in the short run, the quantity demanded will come down, but probably not by very much. However, in the long term, people will find other modes of transport, and therefore the quantity demanded is going to come down much more if we take a longer term perspective. So the point is, the longer the time horizon, the higher the elasticity. And finally, we need to consider whether the product is discretionary or optional, or whether it is non-discretionary. Now, clearly, if you have a product such as a vacation package, which is discretionary or optional, there, if the price goes up, the quantity demanded is likely to go down substantially. So we can say that the elasticity is high. On the other hand, if you have something non-discretionary like bread, here when the price goes up, the quantity demanded will not go down by much. So when you have non-discretionary items, the elasticity is relatively low. Now let's consider the relationship between elasticity and total expenditure. Total expenditure is the total amount that a consumer spends on a product. Total expenditure is simply the price into quantity. So Over here we are looking at our regular demand curve with price on the y-axis, quantity on the x-axis, and here we are looking at quantity on the x-axis and total expenditure on the y-axis. Total expenditure again is price into quantity. Now at this point we have a very high price and quantity is 0. So what is the total expenditure? It is 0 times some high number, which is 0. But as we move down the demand curve, what's happening to price? Price is coming down and quantity is increasing. So price down, quantity is up. In percentage terms, this is going to dominate. So what's the overall impact on total expenditure? If the price is coming down by a small amount and quantity is going up by a large amount, the total expenditure is obviously increasing. So we are going to move like this. And this will continue as long as we are in the elastic part of this curve. So let's say over here the elasticity is high, high being greater than 1. As long as the elasticity is greater than 1, a decrease in price is going to result in a relatively high increase in quantity and therefore an increase in the total expenditure. So up to this point, our quantity is going to increase. Over here, let's say we are unit elastic. If we are unit elastic, then a decrease in price by 1% causes an increase in quantity by 1%. So these two balance out. Therefore, at this point where we are unit elastic, the total expenditure does not change. Now after this, we get to the inelastic part of the demand curve. So now if the price comes down by a certain amount, the quantity will go up, but not by much. So the overall impact is that total expenditure will start coming down. And when we come all the way over here, price is 0, so obviously the total expenditure is 0. So the points to note over here are that as we decrease the price in this elastic portion, the total expenditure goes up, and in the inelastic region, the total expenditure comes down, and it comes all the way down to 0, which corresponds to this point.